the concept of production. Yes. Yeah. So what we have sent is macro. So macro is second semester. This semester we are doing micro. So that's the difference. So it's not the same. So I think they send the wrong document. So you can alert them that what they shared is a wrong document. So that it will also not cause them to set questions in relation to that.
Okay, sir. Pastor, can you also share what you have with us?
Sure. I'll share
Yeah.
it with you.
I will notify
Yes.
the I will notify the school tomorrow about the let's up in the model.
Yes. Yeah, so that is what we are saying, where there is provision of goods, creation of goods or services. And it starts from physical things that we can touch and see, like car checks, to things that we cannot see. And the things that we cannot see always comes in a form of service provision, and that is what we mean by production. So we have these boxes here explaining input, and you see that any production process depends on the factors of production, which are the input. And these factors of production basically help us to appreciate the whole production process. So we have our input here, where this input is what we use in producing. Then we come to the production process, how it actually goes on in terms of the production process. Then we will also establish the output, that is the end product. So, for example, when we use the example in the text, which is talking about what do you call it? Kenke production. We know that we need maize, we need fire, we also need some labor service, and this input will then help us to enter the production process. And through this production process, we end up churning out an output where we'll be able to produce the cake. So you can see that there is a clear connection between input, and these inputs help us to make these particular cake. But you can see that anytime you are talking about production, there is a process. And this process is very, very important because it helps us to understand the different combination of input that will help us to achieve a good outcome. And anytime we are talking about a good outcome, there is a need to touch on two things. We have the technical efficiency and economic efficiency. So here, when we talk about technical efficiency, we are talking about a combination of resources or input to make goods and services. And these economic resources, since they are relatively scarce, there is a need to ensure that the possible combination, gives us a maximum output. So in situations where a producer is combining certain resources or inputs, we are saying that if the producer attains efficiency, then it means that he's using fewer possible amount of input, but he's able to attain higher output targets. Right? So in situations where somebody is using less resources, I know some time back, one lady, whilst I was in school, told me, for me, I can use 10 CDs to prepare jollof. In fact, when she said that, I was surprised because I could use like 500 CDs and still the jollof will still not be jollof. But the lady said, I use 10 CDs. I was like, wow, how can you use 10 CDs to prepare jollof? But what happened? I was surprised she used 10 CDs to prepare the jollof and the jollof. So I was like, oh, okay, then this lady is having technical efficiency because she can use the least possible amount of input to reach a higher level of what. So anytime there is a technical efficiency, it means that it's able to, maximize the use of what input. But this maximization, where when we talk about maximization, is where he reduce the quantity of input but is able to increase the level of what? Production. Which then should tell us that anytime somebody is committing too much resources or input, but it doesn't lead to a corresponding increase in output, you can say that there is no what? Technical what? Efficiency. So let's look at this table which tries to combine various inputs. So we have this input here, we have labor, capital, and we are saying that in one process, you can use one labor and two capital. In another process, you can use two labors and two capital. In another process, you can use two on two. So we are saying that when we look at this same process, for example, if we are still using the kinky example and you want to produce 100 balls of kinky, we are saying that which one is more efficient? You can see that process one used one labor and two capital to produce 100 balls of kinky. Process two used 2 units of labor, but 1 unit of capital to produce the same balls of kinky. And you can also see that 3 used 2 units of labor and capital each to produce this. So when we are comparing process 1 and process 3, what can we see? You can see that process 3 use more labor than process 1. In the same vein, when you are comparing process 3 and process 1 in terms of capital, you can see that they all use 2 capital in producing the same ball of kinky. When we also compare process 1 and process 2, we see that they use fewer input to produce, they use the same level, they use process 1 use 1 labor and process 2 use 2 labor to produce the 10 balls of kinky in that order. But what are we seeing in these particular diagrams or this table? It clearly shows us that when we talk about efficiency, process 1 and process 2 used fewer possible input to produce the 100 balls of kinky. And as a result, process 1 and process 2 therefore are what? Technically what? Efficient, whilst process 3 is not what? Technically efficient. I hope we understand this. Is very, very important to appreciate the technical efficiency where you can use minimum resources to produce larger level of output. So, Elliot, the way you are doing your hands, it can mean different things. So, one is okay. When you do it more, it makes me like you're insulting me. Yes, no, don't mind. So the next point is the economic efficiency, right? And anytime we are talking about economic efficiency, we are referring to the production process, which also leads to cost-related issues. Anytime we are talking about economics, and we usually say that, oh, this person is very, very economic. It means that he's always thinking about cost. He's always trying to see how best he can incur lesser costs, right? So one is lesser. Oh, good. Michael, good. So you can see that one is focusing on cost, and one is focusing on what? The input. So we are saying that economic efficiency looks at the combination of input to produce a desired level of output at what? A lower cost. So technical efficiency is fewer input, but economic efficiency focus on the cost component because you can use a small unit that is very expensive. I remember a lady told me she is going to buy a hair, and the hair is 10,000 Ghana cedis. I was like, what? Said yes, because the hair is called bone straight. I was like, okay, there's no bone. So I was very, very surprised because in situations where you are incurring so much on hair, is it economic or technical efficiency? Because another person can use the same 10,000 to buy 5 hair. So you can see that in that case, it is not economic efficiency because he's incurring so much on one. The next point is that we have to understand the classification of inputs. Inputs that we said that it help us to attain this efficiency comes in various forms. So we have the fixed input, and when we talk about fixed, we are saying that those are inputs that cannot be changed immediately, and in the short term, these inputs cannot be altered. An example is a factory building, capital equipment, and some skilled labor. So always, I usually use a warehouse where they produce sachet water, and there's a new sachet water which is coming into the system, which is NA. NA water is coming gradually. You see it. Yes, NA, or some to you, they are branding it Nana A. Nana A, right? And these are all water that is coming. And we are saying that if we have this building that is producing this water, we are saying that the water can have one plant, right? It's having only one plant. And this land and having two labels who are working tank. So we can see that in this case, the building and the machine is the fixed input because in the short term, you cannot change it. You can only change that in the long term. But the labor is also, the labor itself is also not a fixed input depending on the labor. But here we are seeing that the machine and the building is a fixed input. But when it comes to variable input, the poly tank containing the water is variable input because these are the resources that we use in producing the water. Then the labor is also a variable input because in certain situations, unskilled labor can be changed. This then tells us that to classify a particular input as fixed or variable depends on the period of production. Right? So what do we mean by the period of production? It basically talks about the flow or the duration or the time in which the production process occurs. So there are four main periods in production when it comes to economics. And we have the short run period of production. And this short run period of production is usually where factors of production are fixed. Right? In this case, some inputs are fixed. And the typical example is Nana A sachet water, where the machine and the building is fixed, but others are variable, which can change over time, which is the polytank with the water and the unskilled labor. Then we have the long run period, and this long run period is where all inputs are variable. So in situations where Nana A wants to do this business for 20 years, you can see that as time goes on, Nana A will be able to buy more machines, will be able to get more polytank, will be able to build more buildings in order so that he can develop and pack these things inside. And in the short run, you can see that some inputs were fixed, but in the long run, all inputs are variable. And most people understand it mechanically because they are learning it, but I want you to understand it in a larger sense because whenever a firm is producing, these firms looks at various period of production. For example, if you want to engage in a particular production, you will not only look at the raw material there, but you look at the time. Because when you have more time, you'll be able to change the input. Right? But if you have short time, I don't think you'll be able to change the inputs in that sense. So this gives us a very clear understanding of the various concepts of production. And as I always say, these questions here should be questions that I should be able to answer. For example, the technical inefficiency you should be able to address it very easy. Any question? Any question? All right. So we can go to the next view. Yes, Elio.
Hello, Sam. Sir,
All right.
please, with the growing and increasing change in technology from time to time, can we situate it under a fixed input or under a variable input?
First, so depending on the period you find yourself, if you are in the short run, technology can be a fixed input in the short run, but in the long run, technology can be variable. Right? And it also depends on the technology that you are using, because in some periods, it's very difficult for technology to change, but in other periods, technology change in every second. But usually, anytime you are talking about the short run, we are referring to a maximum of a year in certain situations. And we also have to bear in mind that short run is really relative. What will be short run for a kinky seller might be short run from a spare parts dealer. So we really have to understand the technicalities. But the point that we are trying to say is that for each period in their short run as they perceive, they cannot change all their input. And in that situation, we see that some of the inputs are fixed and some are variable, right? So in your case, it will depend on the technology. But I know some in the short run, some technology will be fixed, but in the long run, all of these will be variable.
All right, thank you, sir.
So we can thank you very much. So we are saying that we are coming to take them one after the other, and especially here we are taking the short run analysis. And since I've explained it out there, I'll not waste so much time here. But we know that short run analysis is where some of the inputs are fixed and others are variable. And you're saying that these inputs or products possess certain characteristics. You have the fixed, the total product. The total product is the maximum output that firms produce, which we all know. Then we have the average product. Average product is saying that on average, how much did you produce? And the best way to find is to divide the total product by V or by the factor, the factors of production, or in other sense by the number of labor or by the output. So anytime you talk about average product is trying to look at total product over what? Over Q, or in some situation where when you are dealing with only labor, it's total product over what? Over L. And so these are some of the things that you have to understand. Then when we talk about marginal product, marginal means the additional reduce the change in total product over what? Over change in what? Over change in Q, right? Or change in L based on what we are dealing with, right? So these are some of the dynamics that we are trying to use. So I know these are some basic concepts that you can easily understand. But we are saying that there is a relationship between the input and output, right? There's a clear relationship between what? The input and the output. And this can be clearly explained using the table that we have here. So we have a table showing 5 columns. The first column talks about you have someone, then the second column talks about the labor units. The total product and also marginal and average product. So we can see that the labor is increasing. Then when you come to the next one, the total product is also what? Increasing in a sense. Average product is also there, the marginal product. So how do we understand this? We said that to find the average product is the total product over Q. The total product over Q. So here we can see that if you want to find 10. This is 10. And here we are dividing it by L, right? So 10 over L here. 10 over L here. So 10 in my machine. So 10, this 10 is the total product over L. L is 1, so it's still 10, right? 24 over 2 is what? 12. 29 over 3 is 13. 52 over 4 is 13. 61 over 5 is 12.2. So you can see that we will be able to attain the average product using the total product and the marginal product. We said that the marginal product is the change in total product, over change in Q or L. So in this case, we are using L. So if you want to find this particular marginal product, we are saying that it's going to be the change in total product, which is what? 24 minus 10 over what? Over the change in Q. Here we are using the rule, so it's going to be 2 minus 1. And that is why we are having what? 40. Right? That's why we are having 40. Then the same way, do the same thing for the other ones, where if you want to find the next one, it's going to be 39 minus 24 all over 3 minus 2. Then you get what? 50. Right? So these are how these tables were being shown. And please understand this table very well and know the formulas. Because if total product is a summation of marginal product and average product is total product over L, then we can say that total product is also average product times L. This is just making total product the subject in this case. So you have to know the various combination of equations and how you can attain these out. But what are we saying here? We are saying that this short run table shows clear situation where we are not bringing, we can see this 1 here, but this 1 is the capital input. And this capital input is fixed and it does not change, right? Since this capital input is fixed and it does not change, it's fixed and it does not change. This capital input is fixed, that's why we are seeing 1 there. So that is what the fixed input. But the variable input will help us to attain the various outputs. And we can observe that whenever we are looking at labor, which is the variable input, as it increases, the total product also what? Increases. The marginal product also increases. The marginal product increases to a point, reaches maximum, and start to fall. The same thing applies to the average product, also increases, reaching a maximum, and also falls. So based on this, we'll be able to draw this particular curve. So let me explain this. I'll come back. So this is the total product of labor, and this is how it's being attained. And I'm saying that this is not drawn in a vacuum, which means that it's not that the person just decided to draw a line. It goes through a lot of processes. So for example, if you have here to be labor, here to be the total product, if you have to plot it, you can see that here is 0 to 8, right? And the total product is 0 to 66, right? So it means that the first one is 0 and 0, so it's this point. The next one is 1 and 10, so maybe this point. The next one is 2 and 24, right? Maybe it's going to be this point. The next one is 3 and 39. So it's going to this point. We are seeing that you can plot these points so that you get something like this. So you can see that this index of here is what is 66, and that's why that's the maximum that we have in here. And we are seeing that this maximum corresponds to what this particular line. So this is 66. So you can see that after 66, we come to what 62, right? And that is what we have here. So the point that I'm making is that we always use the data provided to draw the total product count. So in similar sense, we can also draw the marginal and the average product. Don't forget, it still ranges from 0 to 8 for labor, and here is marginal product. And you're seeing that with the marginal product, we have to start from 10, so 0 and 10, so 0 and 10 here with 10. So let's see here is 10. Then the next one, 1 and 10, so 1 and 10 is here. Then we have 2 and 14. So we have 2 here, we have 14, right? So based on these figures, we'll be able to also draw this average marginal product curve. But the point that we always have to understand after drawing it is the relationship among them. Right? And you can see that as total product is rising, marginal product is also rising. But the moment total products, so I'm talking about here, total product here is increasing at an increasing rate to this point, and you can see that marginal product and average product is rising. Marginal product rises above average product. The moment total product starts to increase at a decreasing rate, marginal product begins to fall, but average product is still rising. When it gets to the maximum, you can see that marginal product gets to the 0 point, and average products start to diminish. So when total products start to fall, you can see that marginal products assume 8 negative values, but average products still fall. So there's a clear relationship. And this is because anytime the total product is increasing at a decreasing rate, it means that any additional increase in input does not lead to a corresponding high level of output. So it contributed less to that particular output. So understanding this is very important, and the relationship between them is, and this information here tries to explain the relationship between them. And we should be able to address these questions as we proceed. But as we have established this relation between the production function, it will help us to understand what we call the law of diminishing return to variable proportion. And in certain situations, they call it the law of variable proportion. Now, what does the law say? This law is saying that all other things held constant, of input increases, initial product increases, but eventually for you input given a fixed input, any additional increase in the variable input tends to increase output, but it will reach a point where output will not increase, but rather diminish. So I use this for the 10 years to explain where I said that we have to read this particular building, and we're having one person who used 2 weeks to read. We are expecting that when we add another labor, we are expecting that we reduce the number of days that we used. You can see that the land, which is a fixed input, the land is a fixed input, so it does not change. So we are saying that anytime we add more variable inputs, we will still be able to reduce the number of days we use in reading. But it will reach a point, where any additional increase of labor will cause the additional time that we have to use to complete diminish. Or let's take it to be that we're having one person and the person was able to produce 10 bags of kinky or 10 bucks, yes, 100 balls of kinky, right? One person is able to produce 100 balls of kinky. We employed another person in addition, so they were two. We are saying that the two was able to produce 200 balls of kinky. We added another third person. The third person came in and they produced 300 balls of kinky. But we employed the fourth person came and they are producing 350 balls of kinky. So you can see that although there hasn't been any reduction, but the rate of change has changed. Here is only 50, while the remaining 900. We employed another person, and instead of they producing, let me say, 400, they also produce 370. Right? But you can see that there has been a rise, a change. But we are saying that the law is saying that anytime you increase a variable input on a fixed proportion, in the initial change stage, there will be an increase in output. But as you are increasing it, since the fixed input does not change, a lot of people will come in and they will not contribute much to what? To output. And that is what the law of diminishing variable proportion tries to explain. But there are some elements of the law which we have to understand. One, the principle states that in the short run, where producers uses fixed input and variable input, which means that if they are trying to explain this law in the long run, it might not work because in the long run, all variable are not fixed, they are all changed. They all change. And they are saying that the variable resource may be labor, tools, and fertilizer, and any resources commonly engaged in production. So these are certain elements that must be available for this condition to hold. The variable resources is applied unit by unit, and each unit is identical in amount and quantity. And this is also another condition for it to hold. And it implies not only in agriculture, but also in manufacturing, retail, and advertisement and mining. So these are some of the elements of the law. But what you have to understand should be able to state and explain with example is the law and what that the law says. Any question? So we are saying that what diminish and what if diminishing and when it diminishes and why it diminishes. So this is trying to explain why the explanation that I was given. So I will take you through this, then we'll then go to the phases of the production. So we are saying that it is a marginal product that eventually diminishes, right? As I mentioned, it does so only after increasing. So as I showed you, anytime you increase the number of labor on a fixed capital or on a fixed input, you can see that as you are adding, it contributes, but I get to a point where additional person does not contribute that much. So that is what this explanation is given. And when you read on it, you'll be able to understand. The phases of the law of variable proportion basically try to explain this particular situation. So we have one phase which is from point 0 to point between this here and here. We have the apex or the maximum here. We have this point here, and we have the negative one. We are seeing that in the phases between 0 and B, these phases shows the increasing return to variable proportion. So if you remember, I said that increase return to variable proportion means that as you increase input, output doubles more than the level of input down. So anytime you are increasing input, it leads to increasing in output, and that is where we are calling here the increasing return to variable proportion. But in point B, it means that you have reached your maximum, and any increase in input lead to exactly the same level of output, which we call the constant return to variable proportion. Then from point B to point C, you can see is reducing. And since it's reducing, we call it the diminishing returns to variable proportion, where a marginal product decreases. And this is because any increase in variable input, which is labor, will end up causing a reduction in output. Then point C is the negative return to variable proportion, where marginal product assume negative value, which means that the people that you are adding add more to cost than to what than to output, which means that they are not contributing anything to. But we have this to note. We are saying that the law of variable proportion is stated here using the marginal product without mentioning what the average product. And this is because the behavior of the total product and the average curves are dependent on the behavior of the marginal product curve. And the total product and the average product rises and falls because the marginal curve rises and falls. So this will be a typical objective question where they will ask you that the total product and the marginal product depends on which curve. You should be able to explain this. And this is a very important point that you have to understand. So what is the economic implication of this one? The economic implication is that it helps producers to determine the best proportion in which they have to employ a fixed input, and which means that the more you are employing people, it should give you an indication that you have to also expand your fixed input. Because if you have a supermarket and in the supermarket you are employing 2 people, they are doing well, customers are coming, so let me add up another year, let me add up. You end up having 10 people managing a small supermarket. And you are saying that so far as you are increasing the variable input, you have to bear in mind that you have to also have to increase the fixed input, which is the size of the supermarket, so that it will help you not to have workers that are social workers. This then leads us to what we call the stages of production. The stages of production. And we are seeing that we have 3 stages. These are things that we have already treated it. We have 3 stages of production. We have the first stage of production where labor, we have the second stage of production, and we have the third stage of production. So these help us to classify the various stages of production. And the stage of production is still in relation to the relationship that I explained between the marginal product, the average product, and the total product. And you can see that in the first stage is where firms usually makes supernormal profit, and at that point the average product is still contributing much. And in the second stage, we tend to experience a decreasing return where the number of labor related to the proportion of capital start reducing, which causes the average product to fall. In the third stage, the firm has reached its maximum, and any increase in the variable input tends to reduce the level of what total output, causing the marginal product to fall negative. So these stages here help us to understand the various stages. And what I've indicated is everything is here, showing the relationship between these 2 diagrams and how it plays. So this is very, very important concept that you have to appreciate. And as I said, you see there is a table here, and this table here is what I was saying that you can present it, especially in the exams, for you to fill and show the calculations. This is a complete the table, determine the level of employment at diminishing returns, and also the amount of behavior. So they can
Hello, sir.
present this table. Yes.
Please, I want to ask that the output is the same thing as product.
Good. So anytime you are talking about total products, you are talking about how much you have produced, and it's the same as the kill, right? So anytime you see total output, in some books they will use total output to kill. In some books they will use kill, but these are all talking about what? The total output. And the total output is the same as the total products that you have what you have produced. So these are the differences. And in this essence, they are all the same, referring to output. But since we are talking about production, we talk about total product, but your total product is the same as the total output that you produce. Clear.
Sir, thank you. Sir, please, I want to find out if the behavior of labor can affect the law of variable proportion.
Yeah, the behavior of labor is very interesting because if the, the, the additional workers are trying to make maximum use of the little that they have in terms of efficiency, they would have done that. Usually, whenever you are working in an environment where I know a particular school where we have uh, 25 teachers, and these 25 teachers teaching 3 classes. And these 3 classes, the first year class or the form one class, 16 students. You can see that the student to teacher proportion is really, really growing. And as a result, some teachers just be paid for like 2 years, they wouldn't be up here. This is because of the size of the person. And we can also see that when the labor is having a good and positive attitude, they can be more innovative and make maximum use of their output. For example, when you travel to the States, they work in hours. And in that hours, when you can, they put everything aside and they work. For nothing. You can see that if it is 6 hours, you work very massively 6 hours, then they will rest. Right? So the behavior of the labor plays a significant role. But in this case, we are trying to hold all other variable costs. That is why when you read the law, you're trying to hold all other variables. A lot of things can come in and can distort the actual relationship. Because when you really look at the skill level of the labor and also affect the finance. And with the skill level, all the laborers having equal skill level, or there are some form of differences. So in order to prevent these kind of complications, to make it very difficult for us to make this analysis, that's why we always say that ceteris paribus, which is saying that all other being which I hope is clear.
Thank you, sir. Yes, sir.
So let's then look at the long run. And the long run is very easy to explain because in the long run, all input are variable, which means that all inputs can change. So we usually use the complex production function to express the long run relationship, where we are saying that to produce output, or in Michael's case, to produce total product. Total product is a function of what? Capital and labor. Saying that this capital and labor means that we have to combine various capitals with various labor to achieve a certain level of output. And because these are variables or this can change over time, we don't have any fixed input in that. Right? So when we proceed, we are seeing that whenever we are talking about this, it means that we can decide to use 3 labor or capital, we can decide to use 2 labor, 5 capital, we can decide to use 5 labor, 2 capital, and you can see that we are using different combination of input to produce some level of output. And you are saying that anytime we show these various combination of input, but it yields the same level of output, we are then talking about what we call the production or the isoprocess. So I always make this example that somebody can say that you give me 2 plantains and one cassava, I'll prepare you. Another person can say, give me half plantain and 2.5 cassava, I'll prepare you. So you can see that they are all using different combination of input, but they are all preparing the same level of output, which is what? 2 balls of what? And you're saying that anytime you have different or various combination of input, but we use that to yield the same level of output, we are referring to what? The isoquant curve. And as I indicate, the isoquant curve is always convex to the origin, just like what I've done here, since it shows the diminishing marginal returns of this case. So let's use this example that we have here to explain. So here we have capital units labor. In case A, they use 8 capital and 1 labor, and they're able to produce 2,000 units. They can use 4 capital and 2 labor, and they will still be able to produce 2,000 units. In labor 3, they can use 2 and 3, and they can produce 2,000 units. 4, they can use 1 and 4, and they can still produce 2,000 units. And what is it telling us? It's telling us that they are using different combination of inputs, but they can all produce the same level. So that's what we have here. So this is A, B, C, and we are saying that these points have some coordinates. Right? And when you join these coordinates, we end up getting what we call the isoquant curve, where this is 2,000, 1,000. You're able to produce 2,000 units. So what is the isoquant? And that's the definition here. We are saying that it is a combination. It's a combination. It shows a combination of input that yield the same level of work, same level of work. So it's very, very important for us to understand these curves. But it's also very important to understand the isoquant maps, because the isoquant, this isoquant is 1,000, or yes, let's take it to the 1,000. And this isoquant is what? 1,200, which means that the further the isoquant curve from the origin, the better the the unit that you'll be able to produce. So it's very, very important to understand that. Okay. But there's also some characteristics of the isoquant, and I've already touched on one. And one is that, so let me go through them one after the other. The first one is that the isoquant curve is negative sloping. As we can see, it is negatively sloping. And we always say a curve is negative sloping when an increase in one leads to the reduction of the other. So let's say that this is the isoquant curve. As this particular input, capital is increasing, you can see that labor is also small, but capital is a lot. As we come here, you can see that capital has reduced, but labor has rather increased. As we come here, you can see that capital has really reduced, but labor has increased in size. So that is what we mean by the isoquant curve, which is a negative sloping curve that shows that if the quantity of one input decreases, it leads to the quantity of other increases. And if the level of output is, but the level of output remain what the same, and that's what I've explained here. So this is one. The next one is that the further away from the origin an isoquant curve lies, the higher the level of what output shows. And I've also explained that with this information that I have. The third one is that the isoquant curve does not intersect. Very, very important. Anytime you are drawing an isoquant curve, you shouldn't see the isoquant curve intersecting. They are always parallel, which means that they lie above each other without crossing each other. So this is what we mean. The isoquant curve should not intersect in this way. So the next one is that the isoquant curve is always convex to the origin. Convex to the origin, we have two forms of curves. We have a convex to the origin, and we have concave, right? So this is a concave, the PBF is a concave, but this is a convex. Right? So we are saying that it should be convex. Okay. But what is the slope of the isoquant curve? Anytime you draw a line, you can find the slope. We are saying that the slope of the isoquant curve is for me. It defines the amount of input that one must give up in order to gain more of the other, right? But to sustain, and in doing that, we still have the output was unchanged, right? Anytime you are finding the slope, and you can see that when you look at this slope, right? When you look at this slope, it's showing um, two situations. It's showing the distance from here to here, maybe K1 to K2, and it's also showing the distance from here to here. It's showing L1 and L2. So this is saying that when you find the difference between K and L, you get the slope of what? The isochrome is the marginal rate, and that's what we have here, right? That's what we have here, showing the change here, showing the slope. And here, don't forget, this line is not position wall. It should rather be on the isochrone curve, which is this, not where it finds itself. And what I was saying is what they have done here. This is trying to explain isochrone curve. But this isochrone curve is always gives an indication that there is always what we call a change, right? So you can see that we are finding the change in K, change in L, and it's going to K1 minus K2, and L1 minus L2, right? And that's what we are trying to explain. But these isochrones is always, they are always faced with what we call a budget constraint. And the budget constraint is where we say that although they want to combine different level of input, but they will be faced with some monetary constraint where they have to spend within their limits. And that helps us to understand the law of diminishing marginal returns very effectively. And this curve, which shows the budget constraint for these producers, is what we call the ISO cost. We can see that here, we are seeing that C is equal to PK times QK. And here, don't be confused. It's rather C equals P is rather C equals P substitute K, which is the price of capital, times the quantity of capital, right, plus the price of labor times the quantity of labor. So it's not K, is rather substitute, right? And you are saying that if you want to know the amount that you have incurred in this production process, it is the price of capital times the quantity of capital that you have what? You have purchased. And also the price of labor times the quantity of labor that you have purchased. So it clearly shows the various combination of the price and the quantity for each input, which will help you to get the cost that you have incurred. So, for example, if you want to produce a sachet water, as I was saying, you need the land, you need the building, the capital. How much did it cost you, and how many did you acquire, and the fuel? And labor, how many people did you employ? How many water tanks did you get? What is the price of them? When you put them together, then get it. And when you put all this together, you then tend to know the cost that you have incurred in producing that particular food, and that will help us to get this. But you can see that this budget line, or the isochrone line here, is showing three cases. We have the attainable region and the unattainable region. The attainable region tells us with that money is just like me giving you 100,000 Ghana cedis and you saying you are spending only 5,000. It means that you can spend 5,000 out of this 100,000 or 10,000 Ghana cedis, but there is more for you to spend. We are saying that this area here is attainable, but it's not the maximum, because there is more for the person to spend. Any point along this line is the maximum, because that means you are making maximum use of the money. And that's what we refer to as what the ISO cost line. But there are certain areas, any area outside this ISO cost line is showing that you cannot spend. And it means that it's something that is unattainable. And I always say that this happens because most people earn a salary of 2,000 a month, but they want to live and spend 5,000 a month. It doesn't happen. If you earn 2,000, you can just rate your expenses to be below the 2,000 or even maximum of 2,000. But you cannot spend above 2,000, which we are saying that that point is what? On. So because of time, I do expect that you sit down and go through these objectives to be able to explain why we are saying that any fence scale should intersect. And these are things that you have to sit down and do these things for yourself. And if you have the book, these areas is for you to write, right? It's for you to write and do some clarification for you to appreciate these concepts very well. Any question?
No, please.
So the next one is the information of the least cost combination of inputs. The least cost combination of inputs is telling us to know how firm produces a particular level of output, the possible cost. And as I mentioned, every firm is producing in their mind, trying to reduce that level of output. So that's very, very important. So we are saying that in this, we have to understand some concepts which you explain. And the first one is the price of the input. But the price of the input is very, very important because it helps us to let us know how much it costs the firm in using or in hiring an additional unit of production. And you know that under perfect competition, we assume that they are price takers. So we assume that price are sale of cost. Then the decision rule of least cost of input. We state that the conditions that must be met for the firm to determine the least combination of inputs are two. One is that the firm must aim at maximizing profit, because if you say you want to minimize cost, or you want to make sure you produce a particular good at the minimum cost, and you don't know or you don't have any profit related intention, then it's very problematic. And the firm faces giving relative prices of input. So in that situation, if the firm is being faced with different prices, the firm will always pick a price that is what relatively cheap. And don't forget, we have already treated the slope of what the indifference curve, and we are saying that it also shows an identity between the NP of K. This when you see this MP is this NP of K and MP of L, which means that we are talking about marginal product of labor and marginal product of capital. So this is NP of K over PK of price of capital, and this is NP of L over price of capital. So don't be confused with how they have written it. So let me use this particular diagram to explain where we are saying that if we are talking about NP of K over price of K, it's equal to NP of L over price of L. It shows that in these two rules, it gives us equal proportion or optimal combination of this input will help us to attain higher level of output. But now let's suppose that the price of labor LK has fallen, right? So if the price of labor has fallen, but the price of K is constant, what happens? We can see that the NP of K over L, P of K will be less than what? The NP of L over price of L. Why? Because the price of labor has fallen. It means that the additional, the marginal product of K will be lesser than the marginal product of capital because the price has fallen. So people can now accelerate in terms of how much they produce. And whenever that happens, it leads to what we call the substitution principle because since they're having different combinations, they can decide to move from using one more input to the other. So let me use this example for you to understand. The first point is saying that when you are using the same level of labor and capital and help a firm to produce condition on their prices. But we are saying that when the price of labor falls, maybe you are trying to pack your sachet water and you have to invest capital in labor. You want to say I'll buy machine, and you want to say I'll use normal labor. We are saying that if the minimum, the amount that you pay the laborers for, what happens? You have to sell some of your machines so that you use that machine to pay the labor because now it's more efficient to use the labor, economically efficient to use the labor than to use the capital. Why? Because the cost of labor has fallen, and as a result, people will prefer to use more labor than capital in producing. And that's what we are calling the substitution. So people will substitute one for the other. After understanding this, in third year, we treat what we call the marginal principle in this particular case. But let's go ahead and look at where we can attain the optimal combination of inputs, where based on the cost that we have incurred. So we have already established that this is the ISO cost, which is showing us our cost curves. And we have this to be the isoquant, which shows the different combination of input that can help us to attain some level of output. And we are saying that this particular point here, where the isoquant and the isocost intersect, is showing a particular case where we have the relationship between the slope of the isoquant, which is the MRST, and also the slope of the isocost, which is the PL over PK. And don't forget, when you see this PL, it's P substrate L and also P substrate K. So that is where we come here. And here it's very important for us to understand because we have two conditions. One, we have this isoquant curve X1, and we have this isoquant curve S2. And you're saying that why will firms not be on isoquant curve X1? You're saying that at that point it's attainable, but it's not what optimal, because it means that they can be on a higher isoquant curve, but we said that the further away the isoquant curve from the origin, the higher the satisfaction. So although we have this, but this is not optimal, the consumer should be under this, and this should be tangential to the isocost curve, which shows that he's maximizing his isocost, which is the different combination of inputs that use the same results, and this meets the budget that he has allocated for that. You can also have another isoquant here, which maybe can be S3, but what are we seeing here? We are seeing that this isoquant curve is not attainable because it doesn't match with the cost, the money that we have to spend, which is the budget line. And this is the explanation that they give to that. So we then have to understand that now that we have understand the equilibrium, we have the isoquant and the isocost curve here, we then have to understand that there could be a reduction in price. As I explained that when there is a reduction in price of labor, what happens? It means that firms will commit more to production of labor. That is causing the labor curve to move this way. So you can see the labor is moving this way because the price of labor has fallen, and firms will prefer using more labor than capital. So here we can see that we had this line, which is the initial isocount curve. But because labor fell, we are experiencing a rise in labor, which is between this point and this point. And based on that, because on the rise of labor, the firm can now be on a higher indifference curve, where you can increase the consumption of labor from L2 to L3 in that form. But you can see that that of capital is constant because the change in price happened not in the uh, capital section, but a fall in labor, which happened in the labor section. But we are seeing that there are three streams for us to understand. And please, this you really have to understand it well. And I'll share a link with you for you to understand the graphing of the substitution effect, the income effect, and the total effect. So I'll share you a link to watch, but please do your best to read this. But to give you a bit of knowledge, we have already explained that we have the budget line, and this budget line, we have this indifference curve here. But we are seeing that in situations where there is a fall in price of labor, this is how the budget line will be, because the same money that we have allocated to for labor, because the price has fallen, we can employ more labor, which will cause us to be on a higher indifference curve. But we are seeing that anytime we have this, we can also draw an imaginary budget line where we cause the consumer to be on the same budget line or the old indifference curve, but he's still having a maximum optimization. I know it will not be clear to you when I send you the link. When you want the link, it's very clear because the graphs here have already been drawn, and I think the best way should have been drawing it one after the other. So I'll send you the link and read this as well, and it's very clear. And it's very, very important for us to understand that in addition to these diagrams that I've shown here, you should be able to take your time to go through this exercise. It will help you. Any question? Any question? Is there any question? I want to hear from you. Is there any question? Any question? I don't know if some of you have reached church. Then some of you were in the class going to church.
So I was in the car going to. I was in the car going to school. I have face to face at 9:30.
No, I'm not talking to you. Why were you in the car?
Yes, I was the one with the videos. I was in the car. Unfortunately, my video turned on. Hey, it's Alex.
I didn't see that you were in the car. Sorry, I wasn't even referring to you. Any question? Any question?
No, sir.
So the last thing that I know you are all in a hurry, but please, as I always mention, try and read the slide before you come, so that you'll be able to ask questions. Let's make sure you read the slides, go through them, so that you'll be able to understand this concept very well. So the last one is the
Sir, please, were you able to share the? Please, are you able to share the model you have with us?
I'll share one of that.
Okay, sir. Thank you.
So we have the next one is the economics of scale. And when we talk about economics of scale, it's a very interesting concept, especially in the long run analysis, which shows the various phases when it comes to how a firm changing input and lead to a corresponding change in output. So let's look at this particular table for simplicity. You can see that we have the unit of capital, we have the unit of labor. You can see that in this case, the input are variable. Yes. This let me check. There's a message. Please have the monitor for this program and the password. Yes. So, Mike, check the message and add related to the group page for the monitor to the group page. So there's a number in the chat, Michael. Take that number and add it, or anyone who can do that.
Okay, sir.
So we are saying that we have this unit of capital, and we have the unit of labor, then we have the total product. So you can see that the capital is changing over time, the labor is changing, and both are changing because we are dealing with what? The long run. And you said that this is the total output. But you can see that if you want to find the marginal, it will be the change between this. So the change between this is what? 150. This is 100. This is 250. So the difference is what? 150. Here is 250. The difference is what? 140%. So you can see that we are experiencing an increase, a reduction in it. So one sense, it is reducing from 150% to 60%. Right? And you're saying that this shows three main skills that every production process goes through. And this is very simple. And we are saying that you can experience an increasing return to skill. The increasing return to skill means that the total product rises more than the proportion of input, which means that you input to labor, but you get an output of an output of, let me say, 10, although 2 has led to 10. So we can see that in this particular graph, this is a change in capital. Right? But this is the change in labor. So what is the difference? Here is 1, here is what?
Yeah, I wouldn't know.
But it's leading to what? A larger level of what? Output. Right? So anytime you double input but output increase by double, we call it what? The increasing return to skill. The constant return to skill is also refers to a situation where there is an increase in input which leads to the same level of output. So here, what is the difference between this? What is the difference between this? You can see that it's leading to a doubling of the output. Right? So anytime a percentage change in input leads to the same percentage change in output, we call that as well a constant return to scale. With a decreasing, yes, Michael.
Yes, sir. Please, I've added the monitor.
Thank you very much. So we have the next one, which is the decreasing return to scale. And the decreasing return to scale is where firm tends to increase their input, but it leads to a reduction in output. And don't forget, when we say a reduction, it doesn't mean that instead of producing 1,200, they produce 600. No. But we are talking about the rate at which it increases, go backwards, but not forward. And that is what we mean by what? A decreasing return to scale. So you can see that here, we are increasing the input, but let's look at what we are producing here or what we are producing here, as compared to the increasing return to scale, where you produce only 1,000 and you're able to increase to this. So these are the three scale of measurement: the increasing return to scale, the constant return to scale, and what? And the decreasing return to scale. But all these hinges on the factor intensity of production. The factor intensity of production help us to know how much capital and labor we commit in producing a particular good. So in situations where we commit more capital in producing that particular good, we should expect that the isoquant curve will lie above or will move towards up. Situations where we are using more labor, you can see that the isoquant curve will I be low because the maximum level of labor falls here and not here. And the same thing applies to the capital. The maximum level of capital falls here and not where we have the QT. So it's very, very important to understand this diagram, and that is what it tries to explain. So please, we really have to understand this concept and production. Very, very important. Since it is based on this, that will be assignment. Because some of you have classes, I will pause, and I know some of you also have questions. I'll pause and ask questions, and I'm ready to answer every question from you or every concern that you have. But I'll make sure I'll send the links, especially to the economics of scale and also the economics of scale and also the substitution and income effects for you to understand. Is there any question, please? Any question? Yes. Yes.
Thank you once again, sir. Sir, please, I want to find out if government regulations or policies can have an effect on the returns to scale, but either by increasing it or decreasing it.
Yeah, government policies do have effects. And as I mentioned, anytime we are trying to do with this, we always make certain assumptions. If we don't make assumptions, there are certain conditions will not work. So you know, government policies really have a massive effect on the lives of people, irrespective of whether they need a lot of input in terms of their production process. It doesn't lead to a larger corresponding level of output because there are lots of factors that could affect this particular situation.
All right, thank you, sir.
Is any other question? Yes.
Sir, please, I want to find out if, like you said, decisions of government can affect the production or the production line or the production time. What if, let's say, inflation? Can it also have a part, or if there is, for instance, recently there was a decrease in the price of fuel, but we realized that cost of production was so high. Why would that be the same? Because we always say that when fuel goes up, prices of goods and quantities go up. But when there was reduction in fuel, we didn't see the change. What will account for that, sir?
Thank you very much. We know that this fuel inflation concept really uses a lot of because it depends on the context, the country that you find yourself, and also it depends on a lot of indicators like the period it takes for a particular country to find this impact. You know, in our case, fuel prices has reduced, but because it is not, consistent enough, and you know that in some few days after they reducing it, they indicated that the fuel price is going again by another percentage. So it becomes very difficult for sellers to respond to this because, as the son mentioned, they have already purchased some of these goods, and they are also bought certain resources using that previous price. So it will take a bit of time. And when it takes the inflation or the fuel prices reduction to maintain for some time. And I know you are into business, and if you want to buy your goods or your raw materials, taking a car which costs you like 500 cedis to the house. I don't think when you are selling your product, you start costing it using the new price, which is around 200 to 300 cedi transportation cost. Because when you do that, you end up running at a loss. So you first would want to sell what you have already purchased at that price. Then if you are going to the market again to purchase, and you get the transportation cost of this 300, it will then reflect the pricing of your product. So it is not usually contemporaneous. But when I say contemporaneous, I mean that it doesn't happen in just a quick second. Now, the moment you reduce the moment you reduce prices, the moment you reduce the price of fuel, it should reflect in the price reduction have to be stable for some time. And that's the problem that we are having. Because the driver bought the fuel yesterday, it was that price, and the next morning you are telling the driver to reduce it because you had it the next morning. The prices has also affected some spare parts that the dealer went to transport from one location to the other, and the dealer has not sold these spare parts. The driver went to buy these spare parts, and they are saying that because they have reduced fuel, they also have to. So these are some of the dynamics that comes in. And the only problem you have in our case is that it is not consistent. The price reduction is not stable. If the price reduces and is stable, we do expect that there should be a corresponding fall in the prices. And some of these also happen because this inflation is usually politics driven. This is, for example, you're having a single digit inflation way around 8 and even below 8% in recent times. But the point is that is it the real situation on that? Or because a political party has appointed a current government statistician, the current government statistician can quote the inflation figure that does not match with the reality. And that's the clear issue that we have, where politics has destroyed the fabric of even our institutions. Because, for example, I always make mention of the previous government statistician who was my lecturer, who even MPP appointed him, but he was really fighting against the MPP because he always told us that integrity is more than political ambition. To get to the point that the MPP themselves wanted to take him off. Why? Because in 2024, he quoted an inflation of 54%, and they were not happy. In just a year or two along the line, inflation rate has moved from 24% to 8%. Why? Because the current statistician don't want to pick the real information on grounds, but still want to adhere to the party the party wishes, where he's trying to paint the picture that inflation is down, but in actual sense, inflation is not. How do we calculate inflation? One way that we calculate inflation is using the CPI, and the CPI is called the Consumer Price Index. How do we get this Consumer Price Index? We get this Consumer Price Index where we have about 250 baskets of goods. And when we talk about basket of goods, we are trying to refer to going to the market and ask them what is the price of clinking, what is the price of rice, what is the price of butter. These things mix up the basket of goods. So, for example, they can ask 5 people in a particular area, then they will find the average. And as Mami is pointing out, price of clinker has not changed, it's rather going down. Price of rice has not changed, it's rather going down. But why is it that after they calculating, we get a less or a small figure? It's a clear indication of political alteration of our figures in order to make the political party become attractive in the sight of people. Playing the devil
Hello, sir.
Yes.
So, sir, well, probably maybe where they are picking their figures for are the hinterlands where probably food is in abundance and the prices are relatively cheap. But if
But
probably they pick from the
go ahead.
if they pick from the cities and well developed areas in quotes, probably the prices would be different.
So it's from the city, but the point here is that it's a modeling, and they can tell you the story that you want to tell. Right? So if you pick from these hinterlands, we don't have to base on that is why we take the average. And we have the Makula market We have the individuals, they use the power market. They pick some from Kaswa, they pick some from Aboboshi. We use the major market. We don't pick it from any other places. And I've been part of this for some time now, the indicators that we use and how we think that this particular information. But I'm trying to
Oh, okay.
let you know how politics can really destroy the fabric of the society. But I was talking about playing the devil's advocate because we know that inflation is also psychological. So psychological because it is, for example, if we usually do that, we go to online shops or we go to shops that we are buying products, and the product is, let me say, 20 cedis. If it's 20 cedis, you say it is expensive. But when you see that it is 19.99, that same person will buy the 19.99 and will not buy the 26. Right? And that is a pure psychological component of consumer behavior. And this is because whenever inflation is low, automatically people believe that things has come down and everything will work. And that's the state we find ourselves. Why is it that things have come down? People are not talking about inflation, but we know that in actual sense it's not reflecting the life of us because this government has moved to deal with the psychological aspect where it has caused people to believe that things are well. But in actual sense, relatively, nothing has changed. They are paying the same cost for transportation. They are paying the same utility, even high utility bills. They are also paying high cost of living. But why is it that nobody is complaining? Because they have been able to address the psychological state of consumers since they are not seeing higher inflation figures for them to talk about. I don't know if you get what I'm trying to say. So these are the two dimensions, and every economy should be able to calm down the tempered and the worries of each people by using these kind of indicators. So these are the nuances and the two sides of the coin, which tend to interface whenever we are talking about inflation. But coming back to the substantive issue, the point that we are making is that all these indicators can affect us. But in my next question, it can really affect us, or we can only see the effect when, in the long run, as we are explaining, the price of the fuel is stable enough. Right? If it is reducing, it's reducing. The reduction should be stable. It shouldn't be that it's reduced in one case. In another case, it increases to a larger case. So it should be stable. Right? And if it's stable in the long run, we do expect that we see um, a corresponding improvement and reflection in our various and levels. Any other question? Any other question? All right. So if there's no other question, I um, think the slides ends here. Yes, it ends here. Please do you don't have time. You have done 1 to 3, and you have to make sure you read through, revise next week, and write the test. Please understand the issue. Don't just read. Understand the issues. When you understand the issues, you don't have to be scared of a test because you can just read and understand. And as I mentioned, in every objective question, we have 2 straight wrong answers and we have 2 straight similar answers. And having these similar answers, the best way to answer an objective question is to first eliminate the 2 straight wrong answers. And you will see, if you have been in the class, if you have read the book, you know that these answers are not really part of what we are doing. You take those two off, then you then decide on the right one. And you have to use this approach when you are not sure of the answer. But if you know your answer, just go ahead and pick your answer and go with it. So these are some of the issues that we have to look at. Is there any question? If there is no question, I have like 7 minutes. I'll give you those 7 minutes to rest and prepare for the next class. Any questions? Thank you very much. Please, the monitor, the officer from code, please, do you have any announcement for the students? Or since I'm told they are writing business tools, is there any information, anything that you have to level it up to them? Please, can you hear me? Okay. If you are not, okay, Mary, you can go ahead since she's not, he or she is not.
Since we have the course monitor, I wanted to draw his attention to the model. Since it's our course monitor, that the model on our Google link is different from the model that you are using. So if they can do something about it.
Okay. So he or she is not talking, but I do believe we can hear you, and I'm hoping that we will do justice to that. But in the meantime, I'm sharing the book to you so that we can.
Thank you very much, sir.
You can also look at it. All right. So, in absence of any question, I think we'll end here. I wish you all the best. Yes.
Yes, sir. Please, because newcomers has joined the group, so I suggest we share the topics again.
I told you last week to provide me with a list of the people so that I shared. That's what I said.
Okay.
That's what I,
yes, sir. I'll provide you the list. I think for us, for us, Nana Apia, I and I think Madam Mame, I think we have our listing.
So provide me with a list of people in this class. Okay. Whether the old, new, let me have the total number so that
okay, sir.
Okay.
I'll do that.
All right. I think another person was saying something.
Was Mame, yeah.
Okay. So
yeah. Michael, what did I do? My name was mentioned. Sir, somebody mentioned my name.
I think there was some noise from your end, so you thought maybe you wanted to say more. So please, we'll end here. We'll meet next 3 weeks to continue. Thank you and have a blessed day.
You're welcome, sir. Please, colleagues, what is the next class? Please share the link for us to join some, please. At 9:30, right? What the next class? Let Nana appear.